Hello everyone, my name is Timothy Lee Grant and welcome back to another video of Leetcoding. Alright, let's go. So today we are going to do another easy. I'm just going to stick to an easy one. Let's see, what is the next easy that I have not solved? Here. Oh, but that's locked, so we're not doing that one. Easy. Already solved it. Okay, easy. Alright, island perimeter. Let's see what's up with this one. Okay, let's go. 463 island perimeter. You are given a row and column grid representing a map where a grid of ij equals 1 represents land and grid of ij equals 0 represents water. So we have a grid which is just row by column. Okay, so it doesn't have to be necessarily square, but it could be. So then in this grid, each of the coordinates can either be a 0 or a 1, and that determines, okay, if it's 0, then it's water. If it's a 1, then it is land. Great. The island doesn't have lakes, meaning the water inside isn't connected to the water around the island. Okay, so that means, like, we can't have land all around here, and then water right there. So all of the water has some connection to the perimeter, which could be like the ocean. Okay, so the island does not have lakes, meaning the water inside isn't connected to the water around the island. One cell is a square with side length 1. One cell is a square length with side length 1. Okay. The grid is rectangular. Width and height don't exceed 100. Determine the perimeter of the island. Okay, so I think what this is meaning is that we are given a grid and there's either it's 0 or 1 representing if there's water or land, and there's only essentially one of this land mass here. And does it explicitly say that there's only one land mass? That's actually, hold on, because let's say that there was a 1 right here. Is that part of the island? You see, because that would not be connected to this main island, but there would be a 1 there. And in the problem, I don't think it explicitly said that there has to be, that there's only one landmass. It said that there was no lakes, meaning water is fully like surrounded by land. It explicitly said that, but it didn't say there's exactly, oh yes it did. It's completely surrounded by water, and there is exactly one island. Okay, cool. So once we find an island, we know that this one thing, this one area, is the only island. So what we can do is iterate through this this graph right here, and we get to our first island, our first land mass. Then what we can do is we can do a depth first search on here, but then we need some way to determine determine the increment to the parameter variable, because for example, look at this square. Actually, we'll start here. Let's say we land here. What does this square add to the perimeter? It's 3. There's 1 by 1 by 1. And then I come down here. Oh, I found another landmass. How much does this landmass add to the perimeter? Well, it's 0. Look, there is nothing right there. Okay, then I come here. How much does this land mass add to the perimeter? Well, it's 3 again. There's 1 here, 1 here, 1 here. This one, it adds 2. 1 here and 1 here. This one adds 2 as well. See? So trying to think of a method which I can determine how much I should add. What I could do is just look at this. So I'm currently at this landmass. And then I say, okay, cool, I want to add. I look to my left and I say, is that water? If it is water, I increment my perimeter by 1. Then what I do is I look up and I say, is that water? If it is, I increment my parameter by 1. Perimeter by 1. Then I look to my right. Then I say, is that water? If it is, I increment by 1. Then I look down and I say, okay, this is land, so I don't increment by 1. So then I have 3. Then I come down here, I look up, nope. I look right, nope. I look down, nope. I look left, nope. And then I continue to do that depth first search, and I'm able to visit all of the land cells. But each time I visit a cell, I have to look up, down, left, right as well. That's a method that's what I'm going to do. All right, let's code it. Let's code this. So, perimeter, we need a variable to store the value we are going to return. So perimeter equals to 0. So now I am going to, okay, so let me think. The stack versus queue. The queue is going to be the breadth first search, because I'm always going to be taking out the element that I saw, or I'm always going to be going to the element that I saw in the order that I saw it. So if I were here, I was here, right? Then I come here, and then I go here, but then because I saw this element and this element, I then now don't go here, I have to go here, and then I go here, and then I go back to this one because that's in the order that I saw it. So that is a queue. This is depth first search. I want a stack. So a stack, I'm going to come here, I'm going to come here, then I'm going to add this element, then this element, then this element. So I'm going to go to this one, and then I put onto the stack this element. So then I immediately take off the top of the stack, which is the one that you most recently put onto the stack. So then I'm going to go to this one, then I'm going to go to this one, then I'm going to pop out and then go to this one and this one. So I think both breadth first search and depth first search would work in this case, because the point of what I'm doing, I'm using depth first search to just visit all of the nodes. So do you visit it in one order, or do you visit it in the other order? It doesn't really matter because it accomplishes the same task, but this is a depth first search, so that's what we're going to do. Yeah, I mean, it's a depth first search problem, so that's why we're going to do that. So I need to have a stack, and it's going to be empty. I'm just going to put that together to make it elegant. So, traverse. Actually, we use a while loop, right? So while stack, and I'll need to find an element and then add it to the stack. So let me just do that. So now while not stack or okay, so what I'm doing here is this while loop, I'm going to iterate through all of, so I found one landmass. Then I'm going to do the depth first search on that stack, and that's going to be the actual meat of this problem. But first, what I need to do is I need to actually find a landmass. I can't just start my depth first search at this first node right here, or this first grid right there. So I'm going to do a while loop through the entire grid, and then I'm going to stop when either I have added an element to the stack, which means I found a landmass and now I can perform that depth first search, or I have visited all of the nodes, the coordinates, and I just haven't found anything. Okay, let me check the parameters. So row is, so columns will not be greater than 100 row. Okay. Either 0 or 1. Alright, so first I'm just going to do if not grid, then return 0. So if there is no grid that they give us for the island, then there's no parameter because there's no island. Second thing is now I need to come here or what? Or no island. So now I'm going to no island equals false. Okay, so I'm going to change this variable if I get to the end of the grid. So I also want to do rows equals length of grid, and calls equals length of grid first index. Okay, and I'm guaranteed that I am able to access this 0th index because I already checked if grid exists right there. Okay, so now come here, and what do I want to do? Just see if see if would a for loop actually be a better solution? Like for index for I in range of rows, for j in range of calls, and then this, I can just delete these two because that doesn't. Okay. No, actually, the while loop might have been a better solution because I just need a way to quickly break out of both while loops. Darn. Okay. While not stack. So while I don't have anything in stack and not, what did I say? Equals false. Okay, so what am I? I'm trying to, let's see, so no island initially is false, so not false. Okay, so that evaluates to true, and this is an and statement, so I need both of them to be true. So this one is true and this one is true. When we get to the end of the matrix and still haven't found anything, this will no longer be true, so we break out of the while loop. Okay, so now do index equals 0, and then at the end of this while loop I need to do index plus equals 1, and I want to do what? I just want to loop through each of those grids. So it is going to be, I'm going to get the grid, so if grid of I 0 if grid of I and j equals 1, then what do? I add it to the stack. So stack dot append, and how do I want to store it? I think I want to do like a tuple of I, j, kind of like that. So I store the coordinates of the grid, and then I just keep popping that coordinate tuple and go to it. So I do that, and then I break and just get out of there. If not, what do I want to do? Else, I don't think I need the else because I have that break. So then what I want to do is I want to go to the next row, or yeah, next column. So j, so if j is equal to calls minus 1, right? Because so calls is the number, it's the length, so it's the number of elements in columns, so 1, 2, 3, 4, and when I get to the 0th 1, 2, 3 index, if it's at the 0th index, I want to loop back around. So I want to go, columns is now going to be 0, and the index is going to be increased. So let's see. Index is now going to be increased, so I plus equals 1. Okay. J equals 0. So I reset J. Okay. So just reset, and then I also want to check to make sure that I'm not way down here, that I went off the grid in the bottom direction. So if I is greater than or equal to rows, then I want to just break out of this. Okay. Cool. So we got the logic for adding an element to the stack. So at this point, we should have at least one element in the stack. If not, this line will not trigger, and then we just go to the return statement, which will return perimeter, which is currently set to 0. So if there is no island, this will not trigger. It will just go down to this return statement and it will return 0. Okay, so another cup of coffee. So what do I want to do? First thing is I also need a set. I realize that because I need a scene set. I need a scene set. Yes, I do. Grid visited equals set. Okay, so let's say that this was land right here. Okay. So what I'm going to do is I'm going to come here, and then 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 you see the problem. Okay, so I need some way to say, okay, I come here, then I come here, then I come here, then I don't go there. I go there, and then I don't go here or there. I come here, then come here, then end it. Okay, so I'm going to say grid point equals stack dot pop, and then I always forget, is pop from the front or the back? Again, it doesn't matter because both will work, but I want to be consistent and I want to do it in the depth first search methodology. So I am going to let's see, so I want to pop from the back, and I know you can do pop 0, which I believe is the 0th index. So I think this is the way I would implement a queue, which would be breadth first search, because I'm taking from the front. But I don't want that. So I'm guessing just by syntax, if 0 is the first element, that if you have no elements in there, that it will take the last element. So this is a queue right here. So I pop, then if grid point in, and what did I call it? I'm just gonna change this to visited. Then what do we want to do? We want to just continue. So continue will not run the rest of this while loop, but it'll come back up to here, and we just pop the next element out of the stack. Okay, so what now do I want to do? Okay, so if grid point, so this is a tuple, right? Okay. Can I just do it like... Is this correct syntax? I don't know. I'm not sure if this is correct syntax, but we'll see if it throws a compiler error. So, okay. I need to check each of the up, down, left, right. If I is less than or equal to 0, then we're guaranteed to be at water right here. And so we don't need to add anything. Like, we don't need to add anything to our stack, but we do need to add to perimeter. Likewise, if we are at this edge right here, so or I is greater than or equal to would that be columns? Columns. Then what do? Then we add 1 to perimeter. So plus equals 1. So now likewise, if j is less than or equal to 0, or j is greater than or equal to rows. No, okay, hold on. I need to figure out if, because I normally represents the number of rows. So, but in this implementation, didn't I do like I comes here? Maybe I need to change things around a little bit. We'll think about that later. I should probably think about it now, but I'm gonna think about that later. So then, if this is the case, I also want to add perimeter. So perimeter plus equals 1. And then each of these, I want to just continue, because I don't want to try to index a element outside the bounds of the array. So continue. Okay, so now I have access to up, down, left, and right because I know that. No, 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 that's not right at all. I do not want to continue because if, let's say that this is land right here. So if I'm right here, I don't want to say, oh, I'm at the ocean. I don't want to say I'm at the ocean because I want to check here as well. So, great. Let's just delete that. Okay. So I am at this node. And what do I want to do? So in my implementation, rows is going to be the length of grid, and that means the number of elements in grid. So 1, 2, 3, 4, right? And then columns is, I'm going to look at this one and say how many elements are in this 1, 1, 2, 3, 4. Okay, and so this one is the first one, which is rows, actually is going to be like rows here. 1, 2, 3, 4, and then this one is going to be columns. So 0, 1, 0, 0, 0, 1, 0, 0. Okay. So I starts off at 0, 0, and then I increment I to go to the next row. And then I increment j up until columns. So why was I confused about this? I can't remember why. I just remember I said that I need to think about that. So anyways, whatever. Doesn't matter. So if I is less than or equal to 0, and that's row. Okay. So that means I'm at the top. So then in this case, I want to add 1 to perimeter. Okay. Plus equals 1. And I don't want to check that element. So I'm going to do an else to say like, okay, so if it is water, don't try to index that variable. If it's not, or sorry, if I'm at the top, then I know that it is water and I don't want to try to index it. Otherwise, I want to try to index that top or the element above it. So otherwise, so if grid, so I'm going to say maybe like check top. I like that. Okay, so if grid of I feel like this is something that's extremely basic. Like I should be able to just do it like that. Like I shouldn't have to think about it. And because I'm having to really think while doing this, it kind of indicates to me that I have not spent enough time doing this and I should really practice more. Yeah, I think that I'm going to have to practice this a lot more because I am struggling. I'm trying to figure out now. I have this j value. Well, hold on. Does that j value go out of the bounds of the array? So I need to make sure that j value is also within the bounds of the array. How do I do that? How do I traverse this? Um, it's something that I should be able to do very quickly, and I'm glad that I am finding this weakness that I have, so that I'm able to kind of like work on it. So, oh man, whoops, I was spinning my coffee, mixing everything up. Darn. Okay, that's unfortunate actually. Do not have a Kleenex anything. Don't want my keyboard to be all sticky. Okay, anyways. So, what was I saying? I was saying that okay, how am I going to do this? So I and J. Okay, so I'm gonna assume that I am on the island. Or that I am. Yeah, so I am on an island. I am on a land element. So I need to check the top. What does that mean? That means I am going to do like grid of I plus 1 and of j. Okay? So j is guaranteed to be on the island, or in the parameter of this grid, because j is guaranteed to be on the island. Okay. I is not, because I'm doing I plus 1. Okay, so if I is if I equals 0, then this guy just keeps escaping. Perimeter plus equals 1. Okay. Else. So now I know that I can go up 1 because I'm not at the 0th. I'm not at the 0th one, so I'm definitely here, here, or here. This I'm at one of these rows, so I can check the one above it. So grid of I plus 1, and now what do I want to do? I want to see if this is land. So if grid plus 1, and then I could do equals 1, but because this is going to be 0 if it's water, or 1 if it is land, I can just index this and say grid of I plus 1 j. And if it's a 1, I know that that's water. So if this if statement triggers, I know that I hit land. sorry, yeah, if it's a 1, it means land. If it's a 0, it means water. So if this if statement triggers, I know that I hit another land. So what do I want to do? I want to add I plus 1 and j to my stack. So stack.append, and then a tuple of I plus 1 and j. So like, let's say that there was let's say that we were going this way. So we hit this, and then I come here. Now I'm checking above me. So I check above, and I say, yep, there's land above me. So I want to add this element, which is what? From this one's frame of reference. It is this one's frame of reference, i's value, plus 1, and it's the same j value. So I just add I plus 1 and j to the stack that I need to investigate. So I add this, okay? Do I need to do anything else? No, I don't think so. Else perimeter needs to be incremented. Plus equals 1, right? I think so. I think that makes sense to me. So I don't add anything to the stack. That seems correct. And I also just increment the perimeter because I know that I'm at water. So I know that I'm at water. Like if this was land here, I look up and it's water. So okay, cool. There's water. Okay. So now I do this for all of the different cardinal directions. So I should be able to go like this. So check bottom. And that's going to be if it equals the column or rows. Minus 1. And that's because rows is the number of elements and I is the index. So if that is the case, then we know that we are at the bottom and we don't look down because we know that it is going to be water. So we just say, okay. And then we need to, if it's not at the very bottom, we need to check the one below us. Actually, that should be below, and this should be above. Okay. So I want to check below, and if it is land, I want to add that I minus 1 and j coordinate to my stack. Okay. Otherwise, I want to increment the perimeter by 1. Okay. Then I do the same thing twice. V. But now I am going to do j and columns. Okay. So now I is going to be the same and j is going to be plus 1. So this is going to be check right. So I'm looking towards the right. So I'm going to increment j. If that is greater than columns, or if that's equal to columns, then I know that I am at an island, so, or sorry, that I'm at the ocean, so I can just say, okay, cool, that is, this line here is going to be the part of the perimeter, because I'm on a land mass here, and here is the ocean. Okay, so perimeter plus 1. Then, if this is, so if I'm not, so if I'm not at the end, I check if I'm at a landmass. If I am at a landmass, or if my right has a landmass, then I just want to add that landmass to my stack. Otherwise, I want the perimeter to increase. Okay. So now I want to check left. And if j equals columns, no, if j equals 0, then I know that I am in this column right here. And so anything to my left is going to be water. So I know that I can just add the perimeter right there, and then not have to check my left anymore. So else, I'm not at the leftmost position, so I need to check if it is water. So if it is water, if this element, -1, is water, or is land, then I want to add that to my stack. Otherwise, I want to increase the perimeter. Is this going to work? Let's try it. Come on. Usually if it says takes a little while, either I have an infinite while loop, or it's it will, oh man. Okay. Oh, and 0 out of 5,000. What? Oh, come on. Wait, let me just run this. Let me run it to see if I can get any more useful hints out of it, maybe? I don't know. Oh. There was no, like, compiler error. So I don't think it was something to do with, like... Okay. Can it run? So I just must have some kind of infinite while loop. Darn. Yeah, no, this is not going to work. Okay, whatever. So, while stack, and I'm thinking that maybe this doesn't get hit, because if this doesn't get hit, then it's going to continually come down to here and try to append things back into the stack. So I'm trying to think, is my notation wrong? So this gives back a tuple. Can I capture it like this? Let me just try this. Break right there, and I am going to print. Typing with one hand now because I have spilt coffee on this hand, and it was the milk coffee, so I don't really want to use my keyboard. Get my keyboard all sticky, so I have to type with just one hand. Anyways, print, and what am I printing? I am doing I want to see I and j. So I and j like this. Dot format, and then I j. Okay, and then I also want to see a grid point. Oops, I should have just done like this, and then grid point. Okay, let's run this, and it should not have an infinite loop, because if here's the problem, if this while loop is the problem, once I hit this break, it is going to just pop on out of there. But it still had a time exceeded, so that makes me think that possibly we were in here. So while not stack. So if stack okay, oh, I see. I think I see. So I need to, let's see. I just checked if this was part of the land. And then I want to increase to the next row. So I need to do j plus equals 1. And then I want to see is whatever, like greater than or equal to columns. Okay. And actually I am going to take off these two lines just because now it might actually have fixed the infinite loop. So, okay, well, let's just try it. Let's submit. Let's see what happens. Did we get it? Memory limit exceeded. Okay. So that error leads me to, because the only way that that could actually happen would be my stack. I'm appending values to the stack, and I keep appending values. So the only thing that so it has to be in this these like calls that I'm appending left, right, up, down. Either number one, this while loop is also an infinite while loop and it's just adding things, and the first thing that failed was that the memory was too large. Or the second thing could be that this while loop is actually not an infinite while loop, but because I'm adding values twice and going back into the while loop and only discarding the value in the stack once once it is deemed to be already visited. So let me come back here. So let's take the example that all of these are land. Okay, so I'm going to start here because I'm going to immediately find that the zeroth grid is land. And then I'm going to say, okay, cool. So now I'm going to come down here to stack. So stack right now contains 0, 0. So I'm going to add this element to the stack. Then I'm going to add this element to the stack. Okay. Then I pop. Actually, let's just say that I go here, then go here, right? So now I didn't explain this right. So all of them are land. I'm here. This is in the stack, and this is in the stack. Now I come to this element. This is in the stack. This is in the stack, and this is in the stack. Okay? Then I come back here, but I realize that this is already invisited, so I can't go right back. But you can see I added that element and then took it away. Now I look here and then add those two, then I come here, okay, like this. Now you can kind of see I'm adding this one, but this one has already been in the stack. I added it from here. I'm not checking before I add to the stack. So essentially what I'm going to do is right here, so if what is this? I plus 1 j and then not in visited. If it's not in visited, then I append. Okay. So I'm going to do that for all of the cardinal directions. So like this, and then I'm going to put that. So I'm looking at I minus 1, and then I append. This one is going to be j plus 1, then I append, and this one is going to be j minus 1, and if it is not in the stack, then I append, otherwise I don't. Submit. I don't like that it's taking a little while. I don't like that. I don't, darn. This 0 passed. 0 out of 5,800. I don't, and it's the same error. I don't like that. I'm at a loss. I don't know. We're gonna go to ChatGPT. Yeah. At that point, it's better to whoops. Okay. The while loop with not stack and not island will never enter if the stack is empty. And oh, I didn't even look if I never set this no island. Okay, whatever. The if condition should be if it's equal to correctly iterate over the columns. When checking the neighbors, so as you can see, this is taking way too long. It should be something that I can do within like 2 minutes. This should be like a 2-minute thing. This question literally is just do a depth first search on a matrix. That should not be difficult for me at all. Like, at all. I should be able to do it really quickly. And so this problem has really opened my eyes that, okay, no, this is something I need to work on. This is I shouldn't do these kinds of stupid errors where I do column minus 1 j and do like the minus 1 or plus 1 or just leave it alone. Like I shouldn't do those. I shouldn't have those off by 1 errors. It should be clean. It should be quick. It should be on my mind, right? But it's not. So I need to practice this. I need to get better at it. When checking, and that's what we're doing, right? Like through these problems, through struggling, that's something that we will do. By struggling, you do get better at this. That was something I remember. What was it? Calc 3, I think it was. Infinite series and sequences. I had my professor in that class. I remember she was before that I was always like I hated the idea of struggling in a concept because I thought it meant that I'm just bad at it, or like, oh, I can't do it, or I just won't be able to do it, or something like this. Like I was always scared to struggle because I didn't want it to define that I couldn't do it. But I remember her talking and she was saying, oh, and not directly to me, she was addressing the entire class. And she said, oh, struggling is good. Struggling means it's giving yourself an opportunity to practice something that you find difficult. Now, don't continue to struggle for 2-3 days. Get help if like you're not making progress, but don't just immediately get help. Like struggle with it, try to understand it, try to mull it over, you know? And it was kind of freeing to be like, "Oh wait, yeah. It is not a bad thing to struggle at all. That means that you are learning something, you're encountering something new, you're stretching your brain." And so, anyways, struggling is good to a point. To a point. Um Okay, so when checking the neighbors, the conditions should ensure that indices are within bounds. But I thought I was doing that. So is it saying I'm not doing it correctly? Or, okay, the if condition, if grid plus 1 should be when checking cells above, similarly for the other directions, you need to mark the visited cells. Okay, so they're using an iter or a recursive function here. Can you use an iterative? Yeah, I want to see the iterative because that's what we did. So I'm going to look at both. I'm going to see how GPT did both. But I want to see the iterative solution first. So here we go. Perimeter equals 0. We got that. That's what we did. Visited is a set. Yep. Stack is an empty list. Yep. This is also the same. Find first land cell to start the depth first search. Great. Wonderful. That's what we were doing. Okay, so they did use a double for loop. And this is also a nice thing about seeing other people's code is to learn like, oh, okay, I might have done something that worked, but it's very inelegant, it's very ugly, and it's inefficient, it doesn't make sense, something like that. Then looking at other people's code, you're like, oh, wow, okay, that's a much better solution, a much better way of doing it. I'm gonna take that. Thank you very much. Okay. So I'm just iterating through the rows and columns. Okay, so if I need to get a drink. So I'm kind of confused why they have two break statements here because I don't think this one is actually necessary. And the reason that I'm saying that is I come here and I check, okay, cool, I found a landmass. I append, so previously stack is empty. Now I append that specific landmass to my stack. So now stack contains something. And then I break, I break out of this for loop. And then I need to do another break to break out of this for loop. So this break statement gets me out of this J for loop. This break statement gets me out of this I for loop. So I do need both. Okay. All right, so here we go. Every time I am unable to solve a problem and I have to go to Copilot to help me understand where I made a mistake, they do this line right here. I hate this. I'm gonna have to. Okay, so let's actually look to see what it means. So I see that it's the 4 directions, and it's a tuple, so it's a list of tuples. So I'm doing a for, so I'm iterating through, and each iteration I get this element, and then this element, and then this element, and that becomes the I and J. So DI, DJ, so that's kind of calculus notation. Change in I, change in J. Okay. Okay, cool. So it's just grabbing the direction that we want to go. So in I in J equals I plus DI, J plus DJ. Okay, so this is the actual coordinate. So I have my I and I have my my I value. And then I am going to either subtract 1, I'm going to add 1, I'm going to add 0, or I'm going to add 0. Likewise with the J, I'm going to take my J, my current J, and I'm either going to add 0, add -1, or add 1. So that's going to be the coordinate which I'm at. That's right there. If out of bounds or water cell, it's part of the perimeter. Okay. So if my I value is less than 0, or J value is less than 0, or it's on the other side, it's down below, right? Like, okay, or grid equals to 0. And we can index these because we've already checked here if it's less than 0. So in that case, we add 1. elif if this tuple is not invisited, so if we haven't visited that set yet, and it is water, or it is land, then we add it to our stack. See, so I thought that this is what I was doing. They're performing this this like left, right, up, down in a different way than I was. I'm trying to figure out how my way differed from theirs and what I need to do to perform this one. Like where did mine fall short? I guess it was all of these things right here. Let me go look at the recursive. So there's a recursive way of doing it as well. So let's go and look at that. So I pass in the coordinates, I and j. If I is out of bounds, so this is the base case. These are the base cases. If we're out of bounds or out of bounds in the other direction, or the we're on water, then we return 1. Otherwise, if we've already visited that node, we return 0. So in this case, we know that we found a new landmass that we have not visited before. So we add it to visited. Perimeter equals 0. I guess it's because this is a local variable to this depth first search helper function. So each time I recursively call it, this perimeter variable is actually going to be different for each function stack that I'm not stack as in the data structure, but I mean function, the computer architecture stack, the call stack. Okay. So this is just going to be initialized to 0. And then I'm going to add the up, down, left, and right, and all of their associated, like I'm going to traverse on my left branch, or my right branch. Then I'm going to traverse on my left branch. Then I'm going to traverse on my up branch and below branch. And I'm going to, each time I do the depth first search here, I'm going to be grabbing perimeters, right? Grabbing perimeters. And then as I come back up the stat, or back up the recursive calls, I'm going to be accumulating perimeter values. And then that's going to be passed up here. And then I return it there. Okay, I think I see it. Again, neither one of these things really is something that I would be able to, even now, like after I've seen it, I do not feel that I could code it out in less than even 20 minutes. I think it would take, I would have to think about this and be like, wait, I do this and then I do. This is not anywhere close to being something that I would be able to do within 5 minutes. So I need to probably like copy and paste these answers into like my iPad or something like that and look at it and try to like burn this into my mind and just muscle memory kind of doing these. Okay, so anyways, if not grid, return 0. Okay, so that's just blocking before, because this is not part of the helper function. This is just saying like, okay, if we don't have a grid, just exit. So visited is a set. Yeah. And then I iterate through I and j, so all of the rows and columns. And then the first time I hit a landmass, I do this depth first search, and then I'll get back some value for that I and j, and then I immediately return it. I don't continue with these for loops. And then return 0, so this would be the case that I ran out of elements here, and that means that there was no land. So it was all water. I never hit this land mass, and I've already checked all of the rows and columns, so then I just return 0 because there is no land, and so the perimeter is 0. Okay. All right, I mean, everything makes sense. Everything in this, like both of these solutions make sense to me. The problem itself makes sense to me. I feel like I was doing the right method, but I am nowhere near where I should be in terms of competency doing a depth first or breadth first search. So like a graph traversal on a 2D matrix. So I think moving forward, I will need to practice significantly on both of these methods. So like recursively and iteratively on matrix, DFS and BFS. I feel like I'm pretty quick now on doing traversals of like trees, depth first search on trees, because I just do like the left, the right, and I have my little node up there. I feel like I'm doing pretty good at that, but I am not. But obviously, this problem has opened my eyes, and I'm not where I should be in terms of understanding, in terms of just like getting those little things down, those little things that really trip you up. I'm not where I'm supposed to be. So yeah, that's how I'm going to be moving forward. Thank you guys so much for watching this video. I'm going to be making a Leetcode video every single day. And so if that is interesting to you, then subscribe to this channel, and I will, I will see you guys later. So yeah, my name is Timothy Lee Grant. Thank you for watching. Have a wonderful day. See you tomorrow.